For this experiment, you'll need saturated calcium hydroxide solution, a dilute solution of hydrochloric acid, some beakers, a magnetic stirrer with a burette and burette clamp, a pH sensor, the LabQuest Mini interface, and a laptop that runs Logger Pro software. Attach the pH sensor to channel 1 of the interface and then connect the interface to the USB of the computer. In the Advanced Chemistry with Veneer folder inside Logger Pro, select Experiment 23, KSP. With a beaker underneath the burette at all times in case of accident, go ahead and add some of the dilute hydrochloric acid to the burette. This initial amount is just to wash the burette and to allow any air bubbles to come out of the tap. Next, fill the burette up to the 0 milliliter mark. Not all titrations need to start at 0. In fact, starting at 0 is usually a bad idea for titrations because it's the only part in the burette that does not have markings above and below. So we're going to fill this burette all the way up until we're at the 0 mark. Using a pipette, measure out exactly 15 milliliters of calcium hydroxide solution. Dispense the calcium hydroxide solution into a small beaker. Currently the lab manual says to do this in a 250 milliliter beaker, but we're going to get better results if we do it in a small beaker because we're going to get a better volume to height ratio that will allow the pH sensor to work better. This is a to deliver volumetric pipette, which means we do not blow out the remaining drop at the bottom of the pipette. The burette is set up exactly at 0 milliliters with the bottom of the meniscus on the line. And then underneath the burette, I have a small beaker with a magnetic stirrer bar and a pH sensor. The beaker contains calcium hydroxide saturated solution, and the pH sensor is reading 12.75, which is highly basic. We're going to now go ahead and start to collect data. Before any acid has been added to the base, we're going to go ahead and press collect and then keep, and in the volume of added acid, this value is currently 0. We're going to briefly open and close the burette tap to dispense out somewhere about half a milliliter each time. So go ahead and read the burette reading, and then in Logger Pro we're going to press keep and add this amount to our data set. So press keep, and then we're going to add 0.8 to this volume set. Okay, We're going to repeat that in increments of about half a milliliter to 1 milliliter until we start to see the line curve. So now we're going to press keep and say 1.4. Continue this way until this part of the line starts to descend. Then we'll make very small changes in volume. After several data points have been collected, you can see that the flat part of the titration curve is about to be over, and we're heading into the steep part of the titration curve. At this point, make the volume increments in your experiment smaller than 0.5 milliliters apiece. After exactly 20 milliliters of dilute hydrochloric acid have been added, our titration curve looks like this. The equivalence point on this titration curve occurs somewhere here, the steepest part, the middle part of the steep part of the curve. We can investigate that by clicking through the pages to look at the first derivative and the turning point here should reveal what the equivalence point is, or the second derivative, which is where the curve crosses 0.